Okay, so today is Review Wednesday. We're going over Lesson 71 in Saxon L71 INV.7. Today's Review Wednesday is going to look a little bit different because we're also going to cover Investigation 7. Now here's the reason why. Investigation 7 goes over balancing equations. This is a huge building block of algebra. So it's really important that we go over it, that we take some time to do a couple problems dealing with it. Lesson 71 is more of something that we have done before. So, I'm still going to go over it, but you will probably look at it as we're going through it. You might say, okay, I've done this before. Lesson 71 is very short. So, even though we're going over Lesson 71 and Investigation 7, it'll be about the normal length of a lesson video. So, what you need, pause this video after I mention it, make sure you have it, is a different piece of scratch paper from your math lesson paper, and a pencil. So different piece of scratch paper and pencil. If you don't have it, go ahead and get it now, pause, and come back. Alright, so, Lesson 71. Finding the whole group when a fraction is known. So we're focused in on this problem here. 3/5 of the fish in a pond are bluegills. So, let's just pause here and say, okay, 3/5 are bluegills, right? I'm going to put BG for bluegill. If there are 45 bluegills in the pond, how many fish are in the pond? So, 45 are bluegills. Okay? So, we know that 3/5 is equal to 45 bluegills, right? So if the 45 bluegills are 3 of the 5 parts, right? So what we're going to do is divide 45 by 3 to figure out what 1/5 is. We can then times that number by 5 and we'll get our answer. So because we have, all right, 3/5, right, are bluegills. 45 are blue. So we know that 45 is equal to 3/5 in this problem. So we're going to divide 45 by 3. When we do that, we're going to get 15. So we know 15 is equal to 1/5. So we draw a diagram here. Problems may ask you to draw a diagram. And we draw 5 parts, 1, 2, 3, 4, 5. And we put 15 in each part, right? Saying how many fish are in the pond. So that would be 5/5, right? That would be 15 times 5. You can use your handy-dandy calculator or old school method, either way. 15 times 5 is equal to 75 fish. So there are 75 fish in the pond. So again, to recap, look at the fraction. Look at the number they give you in the problem. So if there's 45 bluegills is equal to 3/5, then we know we can divide 45 by 3 to figure out what 1/5 is, and then go from there. Okay. So we have example 2. As Sakura went from room to room, she found that 3/5 of the lights were on and 30 lights were off. How many lights were on? So this problem's a little bit different. Let's start with writing down what the fraction is they give us. So 3/5 of the lights, so lights are on, right? 30 lights are off. So, looks a little bit different for us here. So we have 3/5 of the lights are on, but 30 of the lights are off. So we're not going to let our brains freak out here, right? We're going to say, all right, if 30 of the lights are off, and we know that 3/5 of the lights are on, that means 30 is equal to 2/5 here, right? So we can divide 30 by 2 to figure out what 1/5 is. We're not going to be tripped up by this problem. And, surprisingly enough, we're going to get 15 again. So, if we divide it into 5 sections, 1, 2, 3, 4, 5, we have 15 in each. What's the problem asking us? It says how many lights were on. So, remember, we're going to refer back to the fraction here. 3/5 of the lights are on, so we know that 3 of these pieces represent the lights that are on. 15 times 3 is 45. So 45 lights. And that's the answer to our problem. Okay. I want you to go ahead and complete problem A for this. I will give you the answer for sake of time. So go ahead, pause this video, unpause when you're ready to check your answer. Alright, let's recap problem A. So, if 3/5 are boys, 3/5 of the students in the class are boys, and then it says that 15 are boys, it's asking us how many students are there in all. So, we know that we can divide 15 by 3 in this situation to get what 1/5 is. 1/5 would be equal to 5. So then if we make our total over here, we draw a box, divide it into 5 pieces, we put 5 in each. How many students are there in all? 5 times 5 is 25. So there are 25 students. Okay. You should be following along on your scratch piece of paper here. Things are about to get exciting with the scratch piece of paper. So, be ready for it. Balancing equations. This can be entertaining. And as long as you follow the process for balancing an equation, it's not too bad. Let's say we have an equation that is x plus 12 equals 33. This is an equation that is not balanced yet. So, the goal is to get x by itself on one side and the numbers part of things on the other side. So, for this example, what we would do, the equal sign, I like to think of it as the equal sign is a transformer, okay? So, when a number goes across the equal sign, it transforms into the opposite. So, this is technically a positive 12, right? So, in order to balance this equation, it's going to have to go over the equal sign, which is basically turning 12 into minus 12. So, because if we say minus 12 plus 12 minus 12 is equal to 0, right? So that would cancel that out on this side. Now, that would leave x, and then over here we would have 33 minus 12. Well, what's 33 minus 12? Let's check it out. 33 minus 12 is equal to 21. This equation is now balanced. We have x equal to 21. Let's look at some other examples here. So, first thing you want to do is you want to isolate x, right? So, isolate x. Isolate x. That's the goal, I should say. The goal is to isolate x. Take numbers across. So we'll do this. We'll do the number sign. Take numbers over the equal sign. Over equal sign. And then divide if necessary. So, divide if necessary would be like if you have 3x equals 15, if you end up with this, because there's a number with the x, then you would divide both sides by 3, and you would get x equals 5. Okay, so let's do some problems in real time. So we're going to do one together, and then you're going to do one on your own. So, here we go. We have 15 in investigation 7. X plus 2.5 equals 7. So the first thing, so our goal here is to isolate x, right? Get it to the point where x is by itself on one side, and the numbers are on the other side. So, what's the first thing we're going to do? Well, we've got a plus 2.5. So remember, the equal sign is the transformer here. So, we're going to subtract 2.5, because that will cancel it out on this side. And then we're left with x equals 7 minus 2.5. What is 7 minus 2.5? Let's check it out. minus 2.5 would be 4.5. So we get x equals 4.5. Now, I'd like you to go ahead and pause this video and try 16. This is what 16 looks like here. Do this on your scratch piece of paper. 16 is 3.6 equals y plus 2. You're going to do the same thing here. Go ahead and pause this video, see if you can solve it. Unpause it when you're ready to check and see how you did. Okay, here we go. Let's see how you did. First item a bit, so the goal here is to get y by itself, whatever the letter is. Whether it's x or y, you want to isolate it. Get it on one side by itself, numbers on the other side. So the first thing we're going to do is try and get rid of this positive 2. So remember, if it's going across the equal sign, it's transforming. So negative or minus 2, that would cancel it out on this side. Then we're left with 3.6 minus 2 equals y. So what is 3.6 minus 2? It's 1.6 equals y. And that would be your answer. Okay, now let's look at one where division becomes necessary. This is number 17. So, 4w equals 132. So, the 4 and the w are stuck together, right? We can't just subtract the 4 from the w because it's with it, right? If it was 4 plus w or w plus 4, w minus 4, we could subtract or add that 4 over onto the other side. But because it's with the letter, we can't do that. What we can do is divide it away from the w. So, we would do this to both sides, because if I divide 4 by 4, that's 1. That basically just leaves w on that side. Then we have w equals 132 divided by 4. So let's divide it out. 132 divided by 4 is 33. W equals 33. So, I would like you to go ahead and see if you can do 18. Go ahead, pause this video, see if you can do it. Come back, check, see how you did. Okay, so 18 is 1.2 m equals 1.32. So again, we can't subtract 1.2 over because it's with the letter. So, we can divide it out though, lucky for us. Whoops, not 1.32, 132, excuse me. 132, okay. So, we're going to divide 1.2, 1.2. That leaves us with m equals 132 divided by 1.2. 132 divided by 1.2 is equal to 110. And that's our answer for that. Okay, number 19, let's see what happens when we throw fractions into the mix. So we have x plus 3/4 equals 5/6. Now, here's where your calculator is going to come in real handy. So, we have x plus 3/4 equals 5/6. We're treating it the same way. So, we're going to subtract 3/4 from here. So that's going to cross out, and then we're going to have 5/6 minus 3/4. There we go. Let's see what that is. 5/6 minus 3/4. That is 1/12. So x equals 1/12. All right. Number 20 is an interesting one. We have 3/4 x equals 5/6. I want you to see if you can solve this one. Go ahead, pause this video, come back to it. Remember, it's the same thing that we would do with other numbers. 3/4 is with x. So think about what you're going to do. Pause this video, and then unpause it and see how you did. Welcome back. So, we have 3/4 x equals 5/6. Well, what are we going to do here? We can divide by 3/4 to get x by itself, right? So it'd be 5/6 divided by 3/4. I would recommend doing this on your calculator. X equals 5/6 divided by 3/4. which equals out to be 1 1/9. That is your answer. Okay, you're ready to complete any review problems that you need to on the Jamboard. Best of luck.